Okay, so for our project we did snakes and dragons. We just changed the name to Six Dragons because it sounds cooler. So first of all, we put in the main class. This is where the menu is. So it's going to be, you get the scanner and there's the menu input. And so like we put everything into a dual while loop. So it has to do it at least once, and you can just keep playing the game over and over. So you get your options here, and then you just do a scanner for the menu input. So this switch here will test which number you actually put in. So 1 is to play the game. That will bring you into this class here. So it has like the bare bones of the actual game. And then 2 will bring you into stats, and that will show up the stats of the last game. We'll bring you into here and we record the stats in the actual play game. 3 is the how to play. 3 basic, we just print out the actual stat, like the rules of the game. So you just press any number to roll the dice. First person to get 99 points wins. So like a dragon is plus 10 points, a baby dragon is plus 3, a snake is minus 10, a baby snake is minus 3, and then the 1 and 2 on the grid represents where the player actually is. And like if player 1 and 2 are on the same spot, it's just going to be like 1/2. So I'll show that later. If you press 4, it's just goodbye, and then it exits the program. And then if you don't press that, if you press any other number, it's just going to be invalid entry, and then you can press it again. So like the actual do while is like while it's not equal to 4, it will do it. So if you press 4, it will actually exit out, and it will also print this first. So in the how to play, I already described that. So then, like, this is the actual making the grid. So this whole class, these are the variables we used. So it's all the obstacles I was saying. Oh yeah, I needed one for empty slot. So like we're printing the actual values for the grid, not the actual grid itself. So I have something that's going to represent an empty slot, and then I have a black hole as well, and that will bring you back to the, if someone lands on that, they'll go back to the 0. And then beginning and end will just like, it's just like represents where the actual beginning and end is on the grid. So like this is what you print out. The spaces are just so like it looks neater when you print it out. So like over here in the play game, so it will look a lot neater here. So like that, and then oh yeah, so if you bring both of them across, this first slot is going to change to beginning because player 1 and 2 aren't actually on that spot anymore. So now it prints beginning. So then you got your constructor, and you got your gets and sets for all the obstacles. And then in this is the actual making of the grid. So first I had to actually make the array. We made a 1D array because it's a lot easier to deal with moving around the players. So then when we're actually printing it out, we just did after every 10 values, we just went to a new line. And we just made it 100. So down here, this is where we put stuff into the grid. So you to make the actual method, and you just put everything that you're going to put in the grid in the parameters here. Oh yeah, this is a for loop to go through the entire grid and just check what slot you're on. And I did, if you're on position 98, which is the second last position, it's a black hole. On these positions you get a dragon. On these positions you get a snake, as you can see here on the grid anyway. They're all on these slots. These positions here are the baby snake and baby dragon beginning. So like 0 is beginning, 99's end. And then everything else is just an empty slot, which is like these underscores here. So, and then this method here will just like find the player position, and just like the for loop will just find the player position, and then if it's player 1, if player 1 equals the actual like loop, then that position is player 1 2, which means that will print out this here because they're both on the same slot. And then if position equals player 1 position, this thing is player 1, so it will print out this here, and then same for player 2. Oh yeah, this is the enum we made. So it's like when you finish the game, there's gonna be like a line of trash talk. Like if it's a close score, it's not gonna be that bad. It's gonna be something nice. Like they'll just say it was a good game, really. Uh, and then if it's a normal game, like the scores aren't too far away, it's just gonna be a normal response. And then if it's like really far apart scores, it's gonna be like an insult basically. So I had the random number generator for the num that I'll show in a minute, which is here, and then the responses, like I said, it's the nice, average, and mean. So to get the constructor, and then so basically you got your switch for the responses. Oh shit, shoot. So you got your switch for the responses, and then so the nice ones, it's going to do a random number generator, so like 1, 2, or 3, and it's just going to be any random ones of these. And then for average, it's 3 numbers again. No, 4 numbers. I should change that. Sorry. So there's going to be 4 things you can say, and then in the mean ones, there's going to be 13 things you can say. So I'll change that as well. We're just adding stuff a minute ago. So just like as the score difference gets bigger, it's just going to be a harsher response, really. And then in the play game, the ones I'll be describing is where's print grid. So this method here is going to print the actual grid. Like we didn't want to print the actual array, because then it would be like you'd have your square brackets, you'd have your commas in between each one, and it wouldn't line up properly. So we just printed the values in each slot because it looks a lot neater. So basically, you just call it, really, and then you like call the actual method in the grid. So this one here, call this here, and then since all of the variables in the grid class are private, I had to use gets instead. So then I could actually use them. So then after that, I called the player locations. So this goes after the make grid, because like it wants to like override it basically. So it goes afterwards. So I made a loop to go through the entire grid, and then I made it so like on every tent, after every tent value, it goes to a new line. So this one here, so it goes to a new line like that. So I just made that with like position mod 10 equals 0. So like 10, 20, 30, 40, like that. So then you just print the actual grid position. So it's just going to go through 1, 2, 3, 4, 5, and then when it's 10, it goes to a new line like that. Oh yeah, and then the side response one. So this whole method here is if player 1 wins. Originally I had it so like in the same method, but it just didn't really work, so I just split them into 2. So like this one here is for player 1. So you're testing, really, like if there's a difference between 10 when player 1 wins, because he's the winner, it will find a nice response in the trash talk, and it will then like output the actual response. So it will bring you over here, nice. So it will bring you to nice, and then it will just do the random number generator and just find a random one of these 3. And then it basically does that for each. So okay, so the average responses are like, well, like it's not a close game, but it's not like a really bad game at the same time. So then that will bring you here. So average, it will bring you here, in here, and then it will do the random number generator again. So it'll just pick one of these 4, and it's just the same thing for. So the else is just all the mean statements. So it'll just bring you into mean and do the exact same thing and just find a mean reply. And then decide response 2 is just the same thing as decide response 1, but instead it's just if player 2 wins the actual game.
I'll be starting off with the play game class. I imported everything here. The play game class implements the interface for play game. This is basically a library of all the methods that are used in the play game class. And here's all the variables, which is the player 1 position and player 2 position, the dice roll, the round that the player's on, and for the stats it's the big dragon, the small dragon, big snake, small drake, snake, black hole, and the total dice you roll, and this is the total dice used. This is all the variables being initialized, constructors. Then we have the set methods for each of them and the get methods for each of them. Next in the play game class, we have a scanner object and a random object. And this prints the grid here after a play game. And this is during the game. We have a while loop so the game doesn't end after the first turn. This shows the round of the player position, the position of player 1. This is the dice, and this is the dice roll. This is for the stats. This shows the dice roll and goes down to the interact method, put which player or the players. This ends the game if the player position is greater than 99. Shows the player position, and it's the exact same for player number 2. And we call the pick winner method, which is down below. This method was explained by Brayden. And the interact is where we made an object for the grid. So if the player, for the dragon, if the player lands on any of these positions on the grid, they go up 10 spaces. Here's if they land on any of these positions for the snake, they go down 10 positions. Or baby snake, they go down. Baby dragon, they go up 3 spaces. And when the player hits the black hole, which is at the second last position on the grid, they go back to 0. Otherwise there's no obstacles hit and the player just stays where they are. And that was for player 1 and this is for player 2, which is the exact same. For the pick winner, it just prints out the game over, player 1 wins, and the winner's response from the enums. Call it here. Same for player 2. And if they both land on the same, if they both end over 99 at the end, it's a tie. This is the enums methods responses. For the stats, we have sum of obstacles hit, which are the dragons, the snakes, and the black hole. And for the average dice roll, we have dice roll divided by dice roll used. The output file name stats.txt is where we store the stats in the file. That's where we print it to. And then we just output all the stats in here in the file. And finally, for the stats, this is just where we read from the file of stats so we can see it in the command line. Now to actually start the game. To start the game, you run the Snakes and Dragons class. Press 1 to start game. Now we can press any number we want to roll the dice. No obstacles hit. Here 2 players hit baby dragons, so they go up 3 spaces. Player 2 wins the game, and here's the enum response. Then 2 shows the stats of the last game. Player 1 ended on 93, player 2 ended on 99. The 6 obstacles hit, the sum of all the dice rolls is 93. The times the dice is rolled is 27, and the average dice roll is 3. this is how to play, which can be done before the game. And 4 is to exit. The output of goodbye. And that's the end of the game.